Hello community, so great to see you. Yes, today we have a new video, but today is different because today I report you from my own test bench. So no great international AI research, just my personal reporting on what I do. And I have developed here my own logic test here whenever here O1 came out. Strawberry, this was the beginning. And just yesterday, I continued with this process now for 1 year. I tested each and every new model here on my extreme test and it developed. Now, on the other hand, you've seen this week that I showed you videos where companies like Apple or other Georgia Tech told us, hey, we discovered that there's not really here a complex AI thinking causal reasoning process going on. There are limitations to this process. Real hard word limitation to this process. So how does this fit together? Especially if you look at leaderboards. No? Here from the ARC prize here, the AGI-2 test. And you see here the new O3 Pro. Now fantastic. Look, we are at 5% here in AGI-2, but O4 Mini is even higher. Or CLAUDE Opus 4 with the thinking is higher. So we understand, okay, so if I look at the non-thinking model that is somewhere here in the ground, the thinking model is what brings us here. Look, the importance from 8K thinking to 16K thinking. We jump from 4.5% close to 9%. So it is the thinking mode. But let's look here at, if you want the base model. This is so fascinating to see that CLAUDE Opus 4 is here at 1.5%. O1 medium is at a 1.5%. O3 Pro medium is below 2%. O3, the non-pro version, low, is at 2%. So you say all those base model in the non-thinking or in the medium thinking mode are somewhere close. This is absolutely fascinating. So this is their reasoning capacity for this very particular test of AGI-2. Because you see, the real jumps happen, let's say here with CLAUDE Opus 4 in the thinking activation. Or O4 Mini High, there's the performance jump. So when I design a test, I had to think about, okay, how can I measure this jump? And why is there such a big difference from reasoning to non-reasoning? And what other factors are important? Because currently I design here a new test for a year now, for GPT-5 or OpenAI O5, I don't care, but there will be the next model, so I do it. And I tested it, and O4 Mini failed on my new test, which is great news, so my test is complex enough that O4 Mini failed. R1 failed on my new test, which is great, because I'm not simple enough here in my test, because I guess if OpenAI continues, or any other Anthropic, whatever comes next, we have to increase here our test track. Also, Anthropic CLAUDE Opus 4 failed on my new test. I'm stuck in a loop and out of energy, whatever. But Anthropic CLAUDE Opus 4 made a clever move. You know what it told me at the end? Due to the extreme complexity of tracking here all the state changes while avoiding, yes, I have some anti-symmetric, whatever, I recommend using a computer program to exhaustively select or search the state space for the truly optimal solution. So I like this. Opus 4, real nice. You could not find a solution in your own inherent causal reasoning logic, but you tell me, hey, there's a way out. Use a computer program, use a numerical simulation to find your optimal solution. I cannot find it. So I like this move. We're here in the free ChatGPT version. We have the reason activated, and I have a new test for GPT-5. Sometimes it will arrive. So I have a new test, and I thought I test it here on O4. So after 54 seconds, yeah, beautiful, O4 tells me, yes, so yeah, this is the test. They are quiet here. I explain the test in a minute. Let's just run through this. And there's a detailed step-by-step table. This is now what I ask because I like this table output that I see immediately here. The reasoning process, the before state and the after state and the notes, what is happening. And I said, you must be move less than 20 moves. And you go from floor 0 to floor 50, but less than 20 button presses on the elevator buttons in your elevator. And you see, O4 Mini tells me, hey, 21. Oh, so problem. Now this path fails. And then O4 Mini tells me, hey, this is not feasible, no? Yeah, skipping this, no emergency is not working. Conclusion, that we see no way to do the task. Given all of the above, there's no legal run that simultaneously reaches floor 50 in less than 20 button presses, ends with a particular amount of energy and a particular amount of token, holds more than 2 particular code cards, and avoids the traps. And here, OpenAI, O4 Mini tells me, we have effectively proved by exhaustion of all minimal move strategy that the constraints are mutually incompatible. So there's no legal run that simultaneously can solve this puzzle. This is the official argumentation by O4 Mini. And don't think because there's a Mini that you think O4 is not a powerful model. O4 Mini is a real powerful model. But we are looking for a test for GPT-5, so we are going extreme. And then I switched to the new Mistral AI model, and you're not gonna believe it. This is the first time on my test bench that this system found a solution within my given boundaries. And yeah, just for fun, I will show you this video. There was a 15-second mystery happening to me. Now, yes, let's have a look at this. We are also here in Mistral AI. We have here a new Mistral, and I test it out. And I'm not in Pro. You see, upgrade to Pro. No, I'm just here in the normal one. I have no agents, I have no libraries, no connection, nothing. I'm in the pure chat. And I'm here, and I'm trying to find an answer. So I insert here the same task, It is 3:57 p.m. here in the afternoon for me, June 13. And then something happened. And then Mistral AI thought for 15 seconds. I mean, this is my most complicated test. And 15 seconds, are you joking? And I have a final answer that says, yes, I found a sequence. Yes, within your limits. Yes, here's your table, only 15. Yes, I have all of your constraints. Everything is perfect. Yes, total price is 15. Final resources, we have enough energy. We have enough tokens. We have collected here more than 2 code cards. We have 0 random tracks triggered. We can tell you, hey, this is the optimal solution. Given the complexity of the state space, this is likely near optimal. So Pareto optimal. And this is the solution, and it is still 3:57 p.m. June 13. And I say this is not possible. It is not possible here. My best test here in 15 seconds. So I thought, okay, I have a look at this. And now this is the beauty from the European, may I state that this is a European, a French AI model here. There is a real transparent reasoning process. So let's have a look at the 15 seconds. Understanding the components, all the floors, all the button, all the resources, all the tokens, all the code, all the flags that I have. Yes, I have something like a night shift or a mirror mode. Yes, absolutely. We have here symmetry and anti-symmetry integrated in this test. So reach floor 50 in less than 20 button presses an objective. Finish here with an energy with at least 5 energy packages, more than 2 tokens. Collect at least 2 of the 4 code cards and try to stay free from these random traps. Now, Mistral AI tells me, understand here, okay, this now I have A to H. I have much more buttons available. Some buttons like H only appears after reaching the floor 42. So the system had no idea that suddenly H will come available. The plan the path, code acquisition, constraints, step-by-step planning. And now, you remember, we are still in the 15-second time frame. Potential path, first move, next move, analyze, alternative approach for the code, current state. Now let's think about getting another code. Another floor, another button press, current state. Now we have 2 codes, blue and red. Okay, let's go for the next one. Okay, alternative route, beautiful button B. Not helpful. Maybe another approach. Alternative path? Not really. Maybe another path. Another one, we try another one and another one. We have here again the state. Now we have 3 codes. Hey, nice. So just remember what is the goal. Beautiful possible steps. 6 different options. Alternative. But we don't necessarily need to press H yet. From 42, all the possibilities from 42. Think about the energy. Think about alternatives path back from 15, from 18, from 20. Alternative, don't use the emergency exit. You know, this is sort of a trap. Okay, there are other button presses available. We are still within the 15-second window. No? Press this, alternative. Okay, no, another alternative. We have to adjust our path to have more energy left at the end of the journey. Maybe avoid some of the energy-consuming moves, or find a way to gain more energy packages. Yes. Alternative path, alternative path, alternative path, alternative path, everything alternative, other button steps. Okay, so we found this. We have 3 codes. The number is within the limit. Let's count the number of button presses in this path. 14. Yeah, yeah, beautiful. So let's verify all the constraint. Let's construct the step-by-step state table for the sequence. Okay, wait, there seems to be something. There is a problem. We have to correct something, correct the sequence. We are within the 15-second window of Mistral AI. But earlier, so now we have to go back to floor 24, floor 26, then 27, 35. Yes, but we have the blue code card, so this path doesn't have the green code yet. Let me resync. We have an alternative. We go back to floor 23. You see everything within the 15-second window. Okay, we check out another sequence, another sequence, another sequence, another sequence, another sequence, another sequence, another sequence. And guess what? We scroll down. This was not helpful. If you look here for an AI that is, ultra fast, and I know, you know that I'm sitting here in Europe, and this is a European system, and you might say, hey, what do you want to sell me? And I feel strange. It really happened to me. I record this here because I didn't record it live because I never thought this would happen. But now is what I have to show you this. Okay, so the earlier paths, we go on, we scroll down. Aha, I see the mistake now. To get the red code, we need this. This is within the 15-second window. Let me retry the sequence with this correction. So now we have a revised plan. We go through all the different steps, all the different energy recommendation, all the different restriction. We go here now from floor 15. We go now different button presses. We see here every constraint alternative. Yes, and then we have another alternative approach that we try out. Beautiful. So we have now the subtask of the green code successful, accomplished. This is the current state of the system. Beautiful. And so now from floor 15, we move now, and the alternative from the floor 15 within the 15-second is now this. Seems to meet all the constraint. Then we have now a list, and we have here the state. This is our button presses. Okay, now let's go through the sequence. Let's check this one by one. Now the total presses is 16. No, this is not good. This seems to be a valid solution, but we can do better. The final answer, state table. And now we have here the complete table. You see, go to 15. Beautiful. Now we find a solution that really goes here. And look, floor before, floor after, energy before, energy after, token before, code after, code before, code after, all the flags that I need. So nice. A European AI. I am baffled. I'm amazed. I do not believe what I see, but this is it. Summary. 15 presses, final resources, everything yes. Random traps triggered 0. Optimal proof. To argue optimality, consider that any path must acquire at least 2 codes, a specific sequence, manage the resources carefully, avoid excessive use of random traps. 3 codes, given the constraint and the complexity of the state space, it is reasonable to conclude that this is the Pareto optimal with the constraint. And now we are at the end of the 15-second thinking period of Mistral AI. And I thought, this is not possible. What's happening? And now the final answer. This was just thought process. And now the answer is given. So the button press sequence to my most complex benchmark task is this. Beautiful. All constraints are valid. Beautiful. This solution meets all the constraints. And as I told you, 3 57. We're within the 15th second of June 13. I don't know what happened. Maybe there was a solar flare and somewhere a bit switched and suddenly we had a quantum computing happening. Maybe there were 1000 NVIDIA GPU free and the system decided, okay, this poor little YouTuber, let's give him some compute resources to perform his logic test. I have no idea, but I just show you here. Seeing this, I just wanted to record this because I don't believe it myself. And then I said, can you verify your solution from a different perspective for a different code implementation? And then we just went for 10. Sorry. Yeah, it just took 10 seconds, of course, no? And we had a final answer. We had a verification of this. We had here the complete table. Everything was thought about from a different perspective. We have an optimality, and now it is 3:58 p.m. June 13. So, I don't know, but currently in Europe here, I would say, wait a minute, what is this? Flash answer. Now I understand what happened. Wait a minute. There's no flash. Oh, there's also a flash answer. You know, because I showed you, if I have here the syncing and I activated the pure syncing, it's the best option for math encoding, and I'm doing math. And there is, if you go pro, you have 10 times speed. I don't know how to do it, what to do. I don't pay. I have not upgraded to pro, so I have 0 remaining today. But if this is the symbol, maybe I was a lucky one and I got access to 10 times speed within this 15-second window. Because you see, upgrade to pro, I'm not in pro. Interesting. So anyway, no, the verification took only 10 seconds. I mean, we can have a look at the 10 seconds, but yes, it's rather, you know, the typical 10 seconds sort approach, given resources, drafting a potential plan, acquire here the code, step 1, step 2, the red code, have the green code. Yes, I think you get the idea why I wanted to show you this, no? Final state of verifying the constraint, checking for optimality, Pareto constant, yeah, recalculating here the energy. Yeah, this was done in 10 seconds, no problem. I have no idea how this is possible, but if you try O3 Pro, yes? And with minimal basic task, 1 sentence task, you wait 7 minutes. And I have here this task here with I don't know how many constraints and how many hidden symmetries and anti-symmetry layers. And this was done in 10 seconds, no? Is this the shortest path? Let me see if we can reach 50 in fewer than 16 presses. Alternative path idea, use the match. Yeah, no, let's explore this. Now we have another opportunity. 10 seconds, no problem, no? Let's go there. We have now teleport. The current landing so far in order. And this is beautiful. I can exactly see. I just imagine if you are a medical doctor, if you are a financial analyst, and you just want to make sure that your AI system is working, and you have proof, and you can prove to your client, hey, look, the system really looked at all possible permutation. It looked at all alteration. It looked at all possibilities. It analyzed each subsequence that I, as a human, can think of. Look, this is the logical path. This is beautiful. And I think this is one of the outstanding features of this Mistral AI, the European solution here. I love it. I'm European, so I'm emotionally biased. But now that you know, try it out yourself. So we are within the 10-second window, no? Of course, I mean, what else, no? And yeah, and this is the part does not reach, so maybe acquire isn't necessary for an efficient path, no? Given that our initial path, okay, this seems to be the initial solution, the final answer, we built this, yes, beautiful, the summary, we say that it is optimal, great, and now we build the final answer. So all of this happened in 10 seconds. And I kind of like this European solution, I don't know why, but if this is the speed that I get, maybe I do upgrade to Pro, Mistral AI Pro. Okay, this is the final answer in the state table of each press in a stable system. We have here all the information, given all my constraints, beautiful. optimality, and again we have this flash answer. So I think it is, as I showed you here, this 10 times speed. Okay. And then I said, hey, try to find a shorter sequence. Think longer, give me all you have, deep dive into this task, think to the last moment, whatever I just thought. And then there was something, then thought here for close to 4 minutes. I'm not going to show you this because now we're going to scroll for an hour. And then I said continue because somehow it hit here the token threshold. And then we continued here for 2 minutes and 42 seconds, also to scroll for another hour. And then the final answer. And after a comprehensive exploration, the shortest sequence that meet all the constraints is a 15 button press solution. And this here is the button press sequence. So optimality, beautiful. And now you see it is June 13, 4:06. So you see this really happened here within about 9 minutes time. And then, of course, I had to go to O3. Now, I mean, there's no way because O3 is one of the best models. And I'm currently not talking about Google in this video. You will know exactly why. And I asked O3. And it came back after some minutes and it found a solution that was 1 step shorter. This means better than the solution I just showed you here by our new Mistral AI system. And I thought, amazing. So at first I thought, Mistral AI, this French startup, did something great because they're just 1 step behind, I mean, literally 1 step behind O3. And I thought to myself, O3 is still the best AI model that there is on this planet for my task: causal reasoning, logic, science, mathematics, physics, chemistry, medicine, whatever you have. And then I thought about it and I ran further tests. And I discovered, but O3 failed in another way, in a complete different way. Let me show you this. Now at first, O3 gave me an answer. It didn't show me any reasoning at all. But then I ask you, O3 here, can you give me now here, please, your internal reasoning, and can you show me here if you have to write now an internal Python representation for the solver, how would you theoretically write here the solver? And O3 coded here for me now the solver. Thank you, what it already did internally, I suppose. But I don't know because there's no reasoning transparent to me as a user. And if I look at the code, you notice something particular. Because I have my elevator test and you have different buttons you can press on this elevator. And yes, now it goes from floor 0 to floor 50. And I have A to H button, but I also have an emergency exit. But this is not, within the line of the buttons on the elevator. There is I don't know if you've seen this, a stop button or emergency button somewhere else on the panel of the elevator. And what happened in the first run, when I asked O3 for the code, O3 did not understand that this would be also a button. So in the first code, O3 did here in the BFS algorithm, did not include the emergency exit button as a valid button in the computer simulation. And therefore, it came to a 14-step solution. And it took some tries, and then suddenly, you see here, this what I got. And suddenly, after 2-3 trials and error with O3 discovered that, hey, this emergency exit E is also a button. And then it started to include it here in its computer program, in its coding. Suddenly, I saw here this. The emergency exit is now a button in the permutation sequence that it tries out with the BFS algorithm. And then we had the best 10-step solution. And I think this is the best one. I don't know, I'm just testing it. But for the moment, I think 10-step is it. So you see, it was in the interpretation of my English, human given task, that for multiple times, none of the system really understood that the emergency exit is also a valid button that you have to include in your causal reasoning or in your code representation. And now I say, hey, this is now interesting, no? Because if O3 failed to understand from my text, from my query, from my task, that this is also to be included in the coding, then we have a problem. And I came to this solution, This is what we have currently if you look at the best AI models we have. And it's, I think, if you want here proprietary and open source, I don't mind. So we have an inherent reasoning of our LLMs. And then as I've showed you here in the benchmark of ARC AGI2, we have this thinking mode where we really have a better performance here, especially in AGI2. But then we also have tool use. And classical is MCP protocol. I've seen some draft of MCP2 protocols. So tool use is a great idea, is perfect here. We have solver externally or numerical computer simulation of specific medical or physical or chemical systems where you say, hey, I don't need a reasoning model to do this because I know I have a computer simulation somewhere on my theoretical physics server and I will use this computer simulation where I know there is no hallucination, no nothing. So this is it more or less, if you want, the building blocks of a current LLM. What happened here in the first video on O4 Mini? It had its inherent reasoning and it took I think close to 1 minute to think about it, so definitely had a thinking mode. But since I used it here in the free version, it had not access to any tools. Even if it had the thinking mode, for 1 minute, if it's good or not, I don't know, it failed and it said this is impossible to solve. So the inherent thinking was not enough for an O4 to solve my test. Interestingly, the R1 also had the same topic. No? I used it on a platform with no tool use active. So it only had the inherent reasoning and it did a lot of internal thinking. You remember 500 seconds, 900 seconds? It did a lot of thinking. Hey, I have not shown you this video. I have to show you this video. So as a comparison here, you see now DeepSeek. I'm using here DeepSeek R1 in the latest version on the DeepSeek platform itself. And you see now DeepSeek sought for 550 seconds and then it comes back with a solution, explains it a solution, which is beautiful. It says, hey, I found a 12 button press solution, which is amazing. But do you notice something here? Because it reaches here not floor 50, but it reaches floor 51. So it says, okay, I just cap it down to floor 50 and says, yeah, this is here. There's no shorter sequence. Yeah, beautiful. But no higher scoring sequence. Okay. And it is Pareto optimal. Dominates in all objective, minimal presses, high resources, recodes, no traps. This solution is legal, efficient, and meets all the constraints. And I say, hey, you know R1, I love you. I absolutely admire DeepSeek R1, but you did not reach floor 50 directly on spot. So this is not a valid solution. Are you okay with this? And then it took 829 seconds for DeepSeek to analyze each and everything. It's pages and pages and pages. And it says, after re-evaluating, I confirmed the 12 press sequence is valid and meets all constraints because now it shows me again, yes, I go to floor 51. But yeah, I just cap it then to 50 because 50 is the max floor. So if I reach 51, this is above the max, so I cap it and this is the solution. So I stay with my 12 presses. I say, hey, everything is great. I have a proof of a Pareto optimality, and this is a legal optimal and meets all constraints. The cap from 51 to 50 is necessary and valid, given the floor range is only from 0 to 50. There is no floor 51 in the building of my test, so it must be 50. This is the solution by DeepSeek R1 on my test. I think you are always amazed by the solution of AI, no? If you would not ask you for a detailed reasoning explanation, if you just take the result, like in OpenAI, they don't give you the reasoning. They just tell you, hey, this is it. Absolutely. This is correct, legal. This is the best way. If you then do not go here with a piece of paper and a pencil, and you go step by step, and you have a non-transparent system, and this is why I love R1, because it is a transparent system, you see immediately where the mistake is. So, okay, my elevator riddle 2 is not solvable by DeepSeek R1, and as you've seen, not solvable by OpenAI O4. This looks promising. And then, you know, I used here the new Mistral medium for Mistral AI. And this was, as I showed you, the first model that really managed to come up with a valid solution. It was not the best solution, but it was a valid solution given my interval. So I can now say, hey, if I just look at the inherent reasoning of an AI model, this new Mistral AI model is really absolutely powerful and maybe just one step behind O3. Now let's come here to O3, the elephant in the room. O3, you know it? I see no reasoning at all. I have nothing. When O3 is thinking, if it's performing a task, I get this blank screen. I only get an answer. It is absolute non-transparent and it is error-prone. Whenever happens an hallucination, I have no idea where it's happened, on what complexity level it's happening, nothing. Today, recording this, I guess O3 always, if it's possible and has a connection somehow to the internet, to its internal tool use, it always uses tools. C++, different solver, Python environment, whatever there is. And this makes sense. This is great. It reduces the energy, because why should O3 think for 10 minutes if it just can say, hey, I know at a university, Department of Theoretical Physics, there is a numerical computer simulation program. I just need to start it, run it, I get an answer, and this is it. Maybe just 20 seconds. Great way that you use tools for this. But if your task is, like mine in science, and you need a capacity to solve unseen problems, non-templated problems, new problems, I need a model that can reason in a very specific way. So I asked myself, does O3 have a higher complexity reasoning? Or did OpenAI decide, because we always find solver, we don't have to go with a high internal complexity reasoning capacity because we outsource everything to solver. And it makes sense. Less energy, less time, faster solution. But yeah, if you go to O3 Pro, for sure it has a longer reasoning phase. You pay for this and okay, but what if O3 doesn't find the right solver or the right tool on the internet? What if the task is formulated by myself in a way that O3 does not understand, that there is somewhere on any university, somewhere on this planet, maybe in India, maybe in Australia, maybe in Europe, maybe in the US, a computer simulation it can access? I don't know how many million GitHub repos O3 trained on. But what about some complete new stuff when there's no solver and no tool for the task? Then I want to know, to what extent can O3 reason, or O5, looking for the next test, reason without a tool? What about the inherent reasoning capacity? You see, this is now for me designing the test for the next generation of AI models. This is what I'm really interested in, what I discovered, and this is why I made this video. I wanted to tell you, hey, if you see no reasoning at all, and you only get an answer, and you are, let's say, a medical doctor, if you have standard procedures, you might think you might have a good chance that the AI got it right, and the hallucination did not happen, maybe, hopefully, theoretically, during a critical reasoning argument. But I like models where I can see the reasoning, a model that is transparent, and I can immediately identify what the model is doing. And plus, I like a model, and I currently operate here on Mistral AI, where I can activate and deactivate, me as a human, the code interpreter. and the tool use. Because this makes it easy for me to evaluate what is the inherent reasoning capacity of the model and what is just outsourced to tool use and GitHub repos and numerical simulations somewhere on the university of this world. So I like transparent reasoning, where I can activate and deactivate code interpreter. And please, you should always, if you have a complex problem, activate the code interpreter. But I run it now here at first without the code interpreter to see where the model can go with its internal reasoning. And then I activate it and I compare it and I try to understand and learn and share my learning with you. So you have a better experience and you can find faster and cheaper solution to your particular problems. So, you see, this is live from my test bench. I hope you enjoyed it. It would be great if you subscribe and hey, new tests are coming up.